Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 24, 2026, just yesterday. It presents a systematic study on training terminal agents, showing that with the right data, a 32 billion parameter model can jump from 3% accuracy to over 27% on the terminal bench benchmark. The paper is titled, On Data Engineering for Scaling LLM Terminal Capabilities. And as we'll see later, the results regarding data filtering and curriculum learning are actually quite surprising. Figure 1 illustrates the overall data pipeline, called Terminal Task General. On the left, the blue panel shows dataset adaptation, which converts standard math and coding benchmarks into terminal-style prompts. Below it, the green synthetic task generation section builds fresh scenarios by combining seed data with a taxonomy of specific skills. These inputs feed into the orange trajectory generation block on the right, where an agent solves the tasks in a Docker environment. The final output, shown at the bottom right, is the terminal corpus dataset. Alright, applying that pipeline yields the performance numbers shown here in Table 1. The top rows list closed-source commercial models, where strong contenders like GPT-5 Mini and Grok 4 score in the mid-20s. However, the bottom section, detailing open-source models, highlights the real efficiency gains. Specifically, notice Nemotron-Terminal 32B on the far right, which reaches 27.4% accuracy. This score actually beats the massive QWin3 Coder 480B model in the second column, proving that high-quality data allows a 32 billion parameter model to outperform a specialized coding model that is over 10 times larger. To support this training, the authors standardize how tasks and responses are handled. Figure 2, on the left, details the task directory structure. Each benchmark item packs the instructions, a Docker file for the environment, and a solution script into one self-contained folder. Meanwhile, Figure 3 on the right shows the agent's output format. The model generates a JSON object with explicit fields for analysis, planning, and the actual commands, ensuring it reasons through the problem before executing any keystrokes. Table 3 now breaks down the full Terminal Bench 2.0 performance. The top block lists closed-source commercial systems, establishing a high ceiling with scores in the 50s. The middle section highlights the starting point for this research. Notice that the base QN3 models score very low, hovering around just 2 to 4%. Moving to the bottom rows, we see the results of the fine-tuning. The Nemotron-Terminal 14B model hits 20.2%, surpassing Gemini 2.5 Flash. This confirms that the data pipeline transforms these base models, achieving a 5-fold improvement on the 8B version specifically. So, Table 4 breaks these gains down by category to show where the boost actually comes from. Looking at the QN3 columns on the left, we see zeros across complex tasks like debugging and data querying, indicating the base models failed these entirely. However, the Nemotron-Terminal columns on the right show a dramatic turnaround. In data querying, for instance, the 32B model surges from 0 to 60%, and in model training, it climbs to 50%. This suggests the dataset is not just sharpening skills, but teaching completely new ones. Actually, Table 7 reveals a surprising finding regarding data quality. The authors compared 3 filtering strategies for their synthetic tasks, keeping only complete trajectories, keeping only successful ones, or applying no filter at all. You might expect the success-only data in the middle row to perform best, but it actually scores the lowest at 5.06. In contrast, the no-filter strategy on the bottom line wins decisively with a score of 12.4. This implies that letting the model see failed attempts provides critical supervision for learning how to recover from mistakes. So, wrapping up, 2 main points stand out. First, precise data engineering allows efficient models to rival much larger ones in complex terminal tasks. Second, learning from failure is just as critical for agents as it is for humans. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.